thanks for being here, and thanks a lot for the organizer for inviting and, preparing this so well. It's so very well organized, this conference, that's crazy, believe me. So today, another talk about architectures, okay? Today you had the framework-oriented architecture, the framework-oriented design with Pedro, then you had Lucas with MVVM, and now we're talking about VIPER, which is another way of shaping your applications, right? And why there are so many talks. And then we can go ahead and talk about Flux and stuff like that. Why? Because after years, after years of development, we figured out that, mobile apps are not a second-class citizen compared to server application, Have you ever found a job for mobile architect? It's very, very hard to find that, while actually it's very, very simple to find for a Java server architect. And this is a trend that is moving, in my opinion, because our apps are much more difficult to build, much more, there is an expectation that they last long, there is an expectation that they are tested. They have a lot of expectations, and in general, it's important to have, a good architecture on your application for long lasting. And why I'm starting like that? I'm starting like that because VIPER is basically inspired for an architecture that doesn't really come from one guy that in 2008, was very, very happy about mobile and started to figure out how to do things. Because in 2008, when Apple, shipped stuff, we were all happy with the UI view control. We were all happy that a view was rendering on that beautiful thing. There was the iPhone at that stage, right? It was just enough for us. But at that stage, when I came from the server side, it was good because it was something much more prettier, something that I loved much more than a console sort of work. There was energy on that, but still, the idea was that there's something wrong with it. We're writing code, things works, I can ship it, but I don't see any sort of organization in here, right? It seems to be a bit random. It seems, glue code, everything all together to make it work. So, again, I'm talking about this architecture because I believe it's one of the most structured, and for some reason, then is one of the architecture that gets a bit more complained because it's heavy, it's big, But where it comes from? It comes from a guy named Uncle Bob, which I bet you know, of course, and this is the inspiration that other guys, which I have a slide afterwards, the Mutual Mobile guys, started from and defined, the acronym and, ported that into the mobile world. Okay, so this diagram here is quite interesting, and there are 2 or 3 things to take away before we dive into VIPER. Okay. One of the first things is that it has this sort of circle, one with inside the other, and there is a purpose of that. It's not like a vertical stack as usual. Every circle represented different areas of the software and responsibility, and the main idea is that the more you go inside, the more your abstraction layer of abstraction gets higher. So, yes, the entity is here. It's called enterprise business rule. What does it mean? It means that in the most, in that sort of circle, which is the smallest is in the middle, you have all the domain entities of your business. So I'm making apps for airlines, right? So what would that be? That would be, an availability. If I have to fly somewhere else, I need to see the list of the availabilities. That would be a booking request somehow, that I can set the destination city, the day that I want to leave. So it has nothing to do with any specific application. It has to do with the domain. Okay, this is the core concept in there. Just around there, so it's a little bit more specific, so it is less vertical on your domain, but a bit more specific to your application, because we go outside in this direction. You have use cases, and they are called application business rules in this diagram. So here, you start shaping, basically, what is your application-specific stuff? So the use cases in general. You will see that this is the layer where you put all your code base that relates to a specific app. So it can be the app for an airline versus another airline, because, I don't know, checking in to an airline, it's a similar process. But if you tried to do it on different airlines, some airline asks you more information than others. This is specific to the application, even if domain is exactly the same, okay? You get more specific. Around that, you start to talk about adaptation, interface adaptation to what? Like presenter or gateways, to the frameworks and drivers. So it's UI in general, it can be web, or database, okay? So it's it's some sort of an approach on application development that layers your software in a way that it's very clear where stuff should live. And this is really important in the moment that you start writing frameworks, because it's very important that you have one important rule, which is this guy over here. You see this arrow? Okay. Dependencies are always pointing in one direction. If you try to achieve this sort of thing, which right now is very abstract, I understand, you will be able to reuse as much as possible out of this. So what is arrow saying? Is saying that use cases can depend on the domain entities, but the domain entities, which are so high level, will not be able to depend on anything else. As well, your presenter can depend on the use cases, but not vice versa. So you get a higher level of responsibility. So the first time I got into this picture, I was confused like hell, because it's not so simple to understand, okay? It took me a long time to figure this out and say, okay, now I get it. So during this talk, I'm going to try to make sure that you understand this, okay? Because otherwise it's difficult to explain. It takes a bit of time. But it's powerful. It's really powerful. So, as I said before, if you have ever seen anything related to VIPER, this is a familiar diagram. You also have the acronym here. And, you know, it's an acknowledgement to the guys at Mutual Mobile that basically came up with this, rationalizing what they did, what Uncle Bob did with the clean architecture to a mobile world. And, you know, we're going to end up on this in a way or another, okay? So, why I have this, this cake here? Because if you think about the inner circle we've seen before, right? Just take this and flip it, and you get this very nice cake, right? So here there are very big, powerful abstractions, because, you know, we have a slice taken out of it. It's based on layers, so it should have been a bit more a wedding cake, but didn't find a picture, okay? And we also have a plate. You know, I promise you that at the end of the conference, I'm gonna make sense, okay, of this picture. But this picture is quite interesting in that. So, in order for you to understand better why we did this, I need to give you a couple of words on the work I'm doing. So. And the mobile architect at Mobile Travel Technologies, which is a company that powers airlines. And so if you think about airlines business, many airlines have to do pretty much the same business, but it is slightly different all the time. Airlines, what do you do with airlines? You book a flight, you check in, you retrieve your booking, you select the seat. You know, it's that business. So, of course, when you're in such a business, but the companies are all premium, okay? Think about EasyJet, Etihad, those are very premium companies. You need to make sure that you are able to maximize the reuse of your code base, and in the same time to give a unique experience, okay? So we started with this sort of goal in our head. And we felt a little bit like that. So when we got this big goal from our CEO, we had a team at that stage, we felt a little bit like that. So running down a slope with a skateboard, with no protection at all, let's see what happens, okay? And at that stage, though, we started to basically defining our VIPER module. We didn't know. For us, it was just pure, let's go and find a way to reuse stuff and make our client unique. We didn't know we would end up here, right? But just bear with me, and I'm going to make the thing quite simple to understand, I hope. So let's go ahead and try to define what is this VIPER module. First of all, in order to do that, we had to challenge ourselves in the question, what is an application? It's not a huge challenge, to be honest, but we have to acknowledge a couple of things, otherwise we get confused. The first thing is, what is an application? How would we want to define an application? Well, to put it very simply, for now, just think about an application as a set of screens that move one beside the other. So this is an example of one of our customers, EasyJet. So you go from the flight search to the availability screen, and after availability, you get the summary of what you're trying to book, right? This is just a chunk of the application. In the beginning, when you think about reusability and how big you want those modules to be reusable, you could start thinking, well, maybe we can have reusability at, I don't know, this calendar level, or this little, I don't even know how to call it, level, or even the cell reusability. You could, but I don't think it works. I don't think it works because it's too granular. You end up with a lot of reusable libraries, and if your business is big enough, you're going to drown very soon in that sort of granularity. there is always a trade-off, right? If you're too granular, it's hard to manage. For sure, if your granularity, it's too big, then you don't reuse anything because it's too big and you can't really take it. So basically what we acknowledge is that our module, logically thinking, would have been, at least at the beginning, a full screen, what a UI view controller, in our terms, would fulfill, okay? And this works well even with child, parent-child containment. So eventually the decision, at that stage we didn't know, worked quite well in general. So going ahead, we said, okay, we want to define a module which is reusable. And what do we want out of this module? What are the properties that we want out of this module? Well, first thing, we want that those modules, it's somehow composable. What does it mean? That we can build applications as a sum of modules, if you like. Okay, so think about an app. It's a sum of screens. So if a screen is our module, we want to make sure that this happens. Also, modules are a sum of components. So the module itself can be built internally and has its own consistency, so people can think about it, right? Black box from the outside world. What does it mean? It means that our module exposes clear API, and this is always strategical, if you're building a framework, if you're building whatever you want to build, exposes clear API to outside world and doesn't tell how it works internally. Because if I build a module which is based on VIPER and it's so obvious and it's so important, can I give it to you as a framework and you don't know anything about VIPER? Most likely no. I want this module to be completely reusable outside of any sort of predefined architecture in general. We want those modules to be extremely testable. What does it mean? We want those isolation checks, which is an interesting word. I have a reference for that, made simple. So I want to make sure that it's easy to test, because let's face it, if you don't test stuff, you don't even have to put architecture over there. If you know what I mean, it's a different level of engineering, if you like. Independent of the user interface, as I said, if we want to create something that has to be reusable in general, has to give the feeling to the user that he's unique compared to the other. Otherwise, we're doing, another sort of business in general. And of course, if we can, independent of frameworks, databases, UI frameworks, and networks. Okay. Later, last but not least, it has to be also simple somehow. Why is that? Because as a mobile architect, you don't impose anything to your team. And it's not your job. It's to consult. It's to say, this is the best way of doing stuff. And if you do this, you're going to have all of those properties for real. And eventually, all the teams, we have more than 8 or 10 teams in MTT, each one with their own, they are free to do what they want, because every team is an agile team, so they can decide their architecture and stuff. They all decide that this was the best way of going ahead. What is, what does it mean that it's simple? That there are small and well-defined parts which deliver a single function in general. So it doesn't mean that that is easy, because easy means mostly at end, you can do it in a second, but conceptually it's simple. Okay, it doesn't have complexity in it. So to give a little bit figurative things, what we want to do is that if those are our modules, we want to end up in something like that. Okay, our app is the sum of the modules. So let's jump and figure out this VIPER and why we choose VIPER on top of other architectures, right? And also, while I'll do that, I'll also explain the VIPER architecture itself. So this is a bit of a sketch. I'm going to try to use what the chief architect taught me to use, which is very powerful. It's called C4 models. If you have never, used that, just Google it up. It's very cool. It's a way to communicate diagrams. I hope it's going to work here. It's the idea is that you give a picture of an architecture from a very high level, and then you zoom in on the component as much as you need. You never end up at the level of UML unless you need it. UML is way too specific, but in general should help us, should help me bring you the concept of what's behind this sort of architecture in a clear way. So at a very, 2,000 feet view, very high level, you have the user on the left, which is interacting with the mobile application we're going to build, okay, which in turn is accessing some remote service in the cloud. Okay, this is as simple as that. It's very simple at the beginning. Okay, So now what are we going to do? We're going to zoom in into the mobile application itself. All right. And what do we see in there? We see the three screens we said before. You know, flight search, that goes to flight availability, that goes to flight summary. On the right side here, that guy changed a little bit. Is not anymore a cloud for me thing that I want to talk to, but is actually an internal representation in the codebase of services and entities. What does it mean? It means that I've built a library. You know, it could be a pod. Usually we do that, right? We have our Git. We write code that does what? Does the networking, receive information like availability, okay? Does the marshalling and unmarshalling with mantle or JSON to an object model. And the object model is defined here. So this is entities. This represents the domain. Has nothing to do with my app. As you can see, it's outside my application, but is available in my domain as a library because my domain is for airlines. And if you have another domain like weather, here would contain, most likely, the API to fetch new weather, to access the weather, but also the model, so the weather object, which contains the day, and so on. So internally here, we have those three blocks that interact with this guy in a way or another. So now let's explode the guy in the middle to see how do we want it to be internally, because eventually that's really important. Okay, let's be very, very trivial here and put the big guy. If it was 2008, we just have dropped a huge UI view controller in there. The UI view controller is in charge of talking. You know, I'm already nice because all the networking, in my opinion, is done here, right? All the networking and database access is not part of my application as an idea of an abstraction, okay? It's part of a library that can be reused by many other applications, okay? It is not specific to me. The UI view controller here, what does it do? Gets pushed from the previous guy, interacts with the user, also can navigate to the node to another guy, and internally displays everything. You know, it's all in there. But what happens then? The standard 1K plus lines of code in the view controller. Okay, it gets messy, difficult. You know, again, this is actually very simple because you know yourself. If you go there and you start, and you have an idea, you start coding like hell for 4 hours, heads down, you make it work. You all make it work. The problem is that you have to maintain that. The problem is that you have to test that if you want to make it production for real, right? So that's not an option. That's just do. Can we do better? I think we can do better. So this is another approach. The basic MVVM approach, which is interesting. So you have here the view, which right now lost its, you know, right now is just user interface and business logic, and no business logic, sorry. So the view ideally gets a model, the view model, renders it, okay? But we are left with, you know, the view model itself has to convert data from entities to the view model itself. You know, as what Lucas was saying in the talk before, I don't know if you were there, you know, it's a sin. You can't bring this entity to the view because if you can technically do whatever you want, but that would be very, very bad because those layers of responsibility are all mixed up. And if you change the domain model, which is very hard to happen anyway, you're going to impact your view. That's really, really bad. Okay, so in some way, then the view model has to come up with other ideas. What could be the, how it's called, is not the controller, it's called the coordinator. No, it's all good, you know, it's just that we have to acknowledge that this is not powerful enough if you want to basically go on a single responsibility principle in general. It's not powerful enough because it does the conversion from the domain model to the view model mapping, handles user interaction, must apply business rules. Because what if I have to interact with 2 or 3 services? You know, it's not too strange if that on the screen you actually present data from 2 or 3 services. You know, remote services, orchestration, and all. It's standard. Routing, okay, it has to do the routing. What is my next screen? Where I'm going? All this kind of stuff. So from this, the first thing that I can remove as a responsibility is this guy, is the routing. So I'm just saying, and guys, sorry, I forgot to mention, this guy here is a UI view controller, eventually. Now it's just a thing in your mind, but eventually, you know, just to give you a grip on reality, this is a UI view controller This is an NS object, or in Swift comparable. Those are just object or even structs if you wanted to, but I would model that as an object. So they're simple to test in general, right? So the router is just in charge of navigating out. So the view model is going to tell the router, please go to the next module, whatever it is. So let's see in an example of a weather-related thing. I can't really use my stuff, the airline example. Let's see how would that router contract be. Okay, the routed contract is a protocol, okay? Weather list router. So here, imagine the situation, that you have the Apple, if I can open this. The Apple Weather app, very simple. You are in the list of the cities that you want to see weather, right? So this is the module. That module has a router that says, navigate to detail. Sorry, it's a bit short and just because of the space. What does it mean? That once someone click on Wuj, I want to navigate to the detail of the weather of Wuj, passing allocation, like click, and now I see the detail of my, and it is responsibility for the next model. So within this module, this is how my router will look like. Also, navigate to add weather location. What does it mean? It means that I can tap a button and go to a module that will let me add weather location. So all of a sudden, you already have a contract for a component that is even trivial to test, because those are the only thing that it does. Okay. Going ahead, we do this because it's just logical to do this. So basically what happens is that what we called view model a second ago, it's now actually a presenter, and the view model sits here in the middle and gets its real, the name, if the name has a meaning. The guy, it's the model of the view. So in my opinion, is an object that only contains strings that the view can render. And this is amazingly powerful in testing, because if you test this guy, you are so confident of what's going to get on the screen that you don't test the view. We don't test the view like unit testing, because it doesn't make any sense. Okay, the view just says UI label.text equal view model dot whatever it is. Who's computed that? Who's calculated that? Usually is the presenter. Okay, and this is again another powerful thing that goes in that sort of design. Let's see how the presenter would look like. So, okay, first question. First mug. Who's talking to the presenter? Who's talking to the presenter? I mean, we don't have many guys here, right? We have, sorry, I'm going back to, okay. We have the view, those are a bit of an explanation. Who's talking to the presenter? You. Who goes the first now? Okay, you have a mug. Remember, you have a mug. Someone has a mug. He's here. Okay, one's gone. So the view, driven by the user, of course, or driven by itself. What does it tell to the presenter? And this is first of all, tell to the presenter, please load the content. This is a trick we need because of UIKit. UIKit tells you view did load, but tells you did load to a UI view controller. So the view has to tell to the presenter, and I think it's even fair, say, hey, presenter, I'm ready. Load my content, please, because it's not my job to load the content. Then what can tell to the presenter the view? The view can tell, presenter, please present weather detail for Wuj, because the user clicked. It doesn't really say the user clicked. It says, please present this, because I know that it's time to do it. Or it also says, presenter, present had weather location, because the user clicked the little plus. Okay, this sort of stuff. The presenter doesn't do animation or stuff. This is the business of the view. Okay, the presenter does this sort of things. And once again, you have a very narrowed and focused component that you can test amazingly easy. So you think, this is a trivial example. Cool. Building app for airlines is not exactly trivial, but we never go over six methods. So those components tend to be very small and very focused on what they have to do. Okay? Who's talking to the view? Oop. Where the hell? Okay. Presenter talks through the view. Okay? view. So what is the presenter telling to the view? View, display location list, because this specific module wants to display location lists. And I give you a location list view model. So this is very, very trivial. The view model there may have, I don't know, a list of weather item. And the view just cycles through, but doesn't have to computate any data. Sorry, an sdate, I mean. It doesn't have to compute anything, the view, because if as soon as the view compute one bit of information, you have to test it. And then you didn't fulfill the goal of the view model. The view model is the model that the view renders, full stop. And you can test this thing like it's going to be 100% on your screen. You can still have bugs in that way, but they're not the bugs that wake you up during the night, if you know what I mean. You catch them very fairly. Or display an error with a message, if there is an error. Here you can have an error view model, whatever you want, but the view is going to display an error. How the view will display an error? We don't say here. We don't know. But this is a contract. And if you fulfill this contract, you can build 22 or even infinite number of UI view controller with completely different design and UI that fulfill this contract and plug them in. Because what do? You can have as a list, and the error is a pop-up. You can have as a collection view of cells, and the error is like a Facebook that goes down, network error, and goes up. You can do whatever you want, and nobody cares beside the very last bit, which is the UI. Okay, this is strategic. The view model, this is just a simple example, is a struct that contains a list of locations. Okay, and each location we just want to display the name and a detail string. So the detail is already pre-computed, so we can test it as well. Okay. All right, what's next? So, guys, if you just guessed the acronym, here you need another component, okay? And this component, is actually very important, and is the interactor, okay? If you watch the Uncle Bob video on the clean architecture, he actually does exactly the opposite way around. He starts from the interactor, as important as it is. Okay, what's interactor doing? The interactor is basically the guy that knows nothing about any presentation logic. Imagine a big bar here, which I should have designed. Knows nothing about the presentation logic. It just knows about services and entities, orchestrates services, applies all your specific application business rules of the specific module you're building. So this guy here usually gets fairly, 100 lines. The beauty of this architecture, at least at my eyes, is that here you have your controller. I don't even care. You want a huge view controller and many views? That's fine. Do whatever you want, because to me that's less valuable than anything else. Interactor, presenter, they are usually 100, 150 lines of code. So manageable, so testable that this is impressive. Sometimes they're even trivial, even too much trivial. But it's always a way of saying, this is how it should be, in terms of separation of concern. So you sometimes go ahead anyway, even if interactor is amazing, just a pass-through, because the service is powerful enough. Anyway, how is the interactor going to look like here? Once again, give me the locations. Okay, the interactor may access the database. Okay, we don't even know. May access database and give you the location right away while it's fetching or synchronizing with iCloud. Okay, you can do whatever you want in there. This, of course, tells you one big thing. This is a synchronous thing, so we don't have to wait on anything, but could be on callback. We don't care. And you can test this as well, very, very easily. So, this is interesting diagrams, because many people ask me, how are those components interacting to each other? And it's very simple. It's so trivial that sometimes user opens the view loads. The first thing that happens is load content, usually, that goes to the presenter. The presenter goes to the interactor and says, can you give me the locations, please? Because I know that when the view loads, the first thing I have to do is to present all the locations to the user. Okay? Interactor does whatever he wants, goes back to the presenter. The presenter usually builds the view model, okay? Unless you have another component, which I wouldn't dare to add here, but we do have another component. Builds the view model. And then what does it do? Tells the view, hey view, display location of view models, okay? And it's as simple as that. So the flow, even if you want to think about it as nothing tricky or so many components. Yeah, it is actually very straightforward. And in the time that the user clicks on which in the list, says present weather detail, the presenter says what? It may do something, we don't know, but usually it doesn't do much, and says, okay, there is a guy that I know which is in charge of presenting the next module, like the weather detail, and you say, present, actually here it does something, because when the view tells present weather details, it's going to give you an ID, ideally, of the which city, okay? It's going to give you an ID. This guy here will figure out in the list of the location that got before what is the actual location they want to navigate to, and tell to the router, please navigate to weather detail. The router will know. Okay, it doesn't care anymore. So the business of the router is just to navigate away. Are we there yet? Nope. Second mug. What's missing? So the flight search, or the module before us, where is he landing to? Remember, we are a black box. We don't want the world to know how beautiful we are or how complex we are inside. We don't want the world to know, because otherwise we miss the point. We're not forcing an architecture that everybody should know and understand. We want to make modules. We want to break the monolith into modules, and we want to have smart modules. So, who's there? What, sorry? Router, it's a good answer if you know VIPER, because it's the standard implementation. The standard implementation goes through the router or wireframe, okay? But the title of this presentation is slightly different than modules with VIPER. It's with Builder. It's your. You have 2 mags now? Just one. Okay, that's yours. Oh, sorry, there's a slide before, but yeah, the idea is no one else, to answer the question of the router, I don't want to give it this responsibility to the router. And why is that? Because of this. This is the standard face of a mock. If you have a mock object, this is standard face. It's dump, right? So if I mock everything around my presenter is so testable that it's unbelievable. So I don't want to give all those components a responsibility that is not its responsibility. So I want a builder. I want a thing that is just responsible of building. And why I want it separated? Because the builder is my key for reusability. The builder, I have a slide, knows how to wire the module components. All those components, of course, are defined by protocols. If you don't use protocols or contracts or interfaces, you're doomed since day one. It's finished because everything is glued together and there is no reusability but no modularity as well. So protocol is Apple, you know, it's great what they're doing with Swift and protocol. You know, they are so powerful in some sense. But they should have pushed on protocol since day one of iOS development. When you hire many iOS developers, you ask them, what is a protocol? Oh, I know. It's for doing, you know, delegation of the table. Yeah, so the delegate pattern uses the protocol in order to, but a contract, the word contract is very, very hard to get out, but it's really, really important because by doing that, the builder can instantiate the concrete implementation of each component. So if you have a different UI view controller, you can create a different UI view controller, and using the powerful dependency injection pattern, so the components themselves, they only depend on abstractions, they depend on other interfaces, they never depend on a concrete implementation, they never create internally, just to give you an idea, the view, which knows the presenter, uses the presenter, would not dare to build the presenter, because the view only knows the protocol of the presenter, knows that there's going to be one day, one presenter that is going to fulfill the contract. But the view will never do a new or a whatever on a presenter. And all of those guys have to be the same, okay? So going back here, the builder is the guy that is in charge of creating all those elements, link them together, and also, that should not have been appeared here, but what is the builder output? If you look at the canonical VIPER implementation, the builder output is there's no builder, but when you build a new module in VIPER standard, what do you do? What would you hand to the new guy? You usually hand the presenter. because logically can make sense, but it's wrong. And the reason why it's wrong is that if you want to be a black box, you are a UI view controller. The UI view controller is the guy that lives on the stack of the navigation, of the tab bar, child-parent relationship. And it's so cool because the UI view controller also is in charge. Sorry, it's not in charge, but being in the UI kit, when something goes, you get deallocated from the stack, it gets destroyed, and if you are represented by a UI view controller, everything else gets destroyed. This big thing here that can seem, if you destroy the UI view controller, gets destroyed. Why in the original implementation is not like that? Because this is more of a central piece of the puzzle. The view, but it's really important for us that our builder has an interface like that. So the weather list builder, so I'm giving you something that gives you a reusable component, wants no input in this case. Please make sure that you may want input. And I'll give you an example in a second. No input in this case. And what you give me, if you can build it, give me a UI view controller. Why? Because from that moment on, I can push you everywhere. And there is no more VIPER around. It's finished. Okay. The VIPER is only for you developer to develop better. So this is why I believe Builder is very, very powerful. And I don't remember what's next, but we are going back to, oh yeah, sure, of course. What I was saying before is the power of dependency injection, the builder, and all the protocol-oriented design, call it whatever you want, that if you give a slightly modified builder which knows my view implementation and my router implementation, you change the look and feel, and also you change the next destination if you want to. All right? So that is where the power comes from. So now let's do a very interesting attempt to do something like that. Boom. Do you remember the inner circles? Sorry. So I was promising you that that would make sense one day or another, and it started to make sense to us a bit late because it's very difficult to think about it. But once you grasp it, you don't want to let it go because it's so powerful in some sense. So here at the service and entities level, we do have our domain model object. So if it's a weather app, here is the API, is the service which I call weather service. Okay, and there are all the models. There is an object that represents the weather itself, an object represents the cities, because when I have okay. So this is of the domain. Doesn't have to do anything with my app in the specific. Then in the INTERACTOR here, I basically use those guys in a way that is meaningful to my app, but I'm still very much away for any representation, any representational, business, because when I cross these boundaries, we start to be in the realm of the presentation. So those are the adapters for what? The view, which is our final thing. It's touching the view at the very end. Okay. And the cake. So now these slides makes a bit more sense, right? You can see it like that. You can even VIPER, you can even make this joke and figure out the acronym. But it is this, right? At the very bottom on the plate, you have your entities and services, which are not your cake, but they're part, you need it, but it's not your cake. Think about airlines again, okay? We build many apps for airlines. Each airline, it's a different cake, but they all stay on the same plate because the domain is the same. Book and check-in is the same thing, okay? At the very bottom, talking with the plate, you get the INTERACTOR. And then the more you go higher, the more you get to the little stars here and the cream. And this changes, all the toppings changes all the time. So when you look at the cake, it's always different, but layers can be the same. Okay, I don't know if the metaphor works, but it was a nice picture, okay? So, do you feel like that? Not yet? Oh, maybe. So let's see, what do we have now? All right. Is it composable? Well, I believe application as a sum of modules makes sense because we have a builder, wants some input parameter. Oh, sorry, the example of the input parameter. If we are building the screen that shows the WUJ specific weather, What is the input parameter? The wood city, because it's not a list of all the city that I've installed that I just query the database, give me everything. I have to say to the next screen, render for what city, and this is the input parameter to the function builder that gives us a UI view controller. So application is a sum of modules which are composable, because UI view controller is a basic. If you can't compose them, there's no architecture in there, right? Sum of components, it's a module. That I think with the builder is very straightforward. It's a black box, so if you see only the output of the builder, you will never figure out how complex, easy, simple it is internally. Up to you. All right, let's run. Testable, I've showed you the face of mock, so it's very easy to test those components. Independent of user interface, which was one of our goals, but I believe is a very, very interesting goal when we talk about reusability on a mobile app, which ideally it's very, very based on UI. And also on framework. I'm not going to go deep into this because we don't have a lot of time. And eventually, this is my personal understanding of it, is also quite simple design in itself. So because the API are simple, if you look at those API, the protocol I put you on the screen, there's nothing magic in there. You know, it's very simple. What is the presenter doing? Oh, this, and this. And even when you start building this sort of apps, it's very, very powerful in general, because you start saying, okay, what is the view going to tell to the presenter? What is the presenter going to tell to? What is the interactor going to do? You start thinking, you know. Oh, sorry. Yeah, how you move data between builder, I think, is straightforward. You're going to get the slides anyway. This is an interesting thing when people ask, okay, but who's weak, who's retain cycles and stuff like that. So the Windows has a strong on the view. This is pretty standard. We need to make sure that the view has a strong on the presenter, which has a strong on interactor, weak on the other direction, and the presenter has a strong on the router. This is to make sure that when the UI view gets deallocated, the UI view controller, sorry, everything falls down. So you don't have to even think about memory. Some say, oh, it's so big, what if it leaks? No, it doesn't, because when this dies, everything falls down, okay? You have this ugly arrow. We basically spent many hours trying to figure out how to remove this, but it's impossible, because the router, which does the navigation, needs a UI view controller. You can't navigate in UIKit without having a UI view controller. So you need to have a reference to not exactly the view, but the concrete, the UI view controller. It smells a little bit, but what can I do? Crossing boundaries. Ideally, you know, those are the inner circles. Ideally, you should, but we don't do it because sometimes fields overkill. You should, every boundaries you cross, change the model, because that would make you safe from changes on the other layers. What we do, and you can do whatever you want, to be honest, is to propagate this model here up to this boundary. We never give the UI view the model that shapes our domain. Why is that? Because what is on the view will never match what is on your domain, because the designer are going to come up with different ideas, maybe have 3 or 4 model of your domain, but the UI view is completely different. So here we have to make the mapping, and we do it only there, to be fair. All right, this is of course something that as soon as you start doing it, you start to think, oh, that's cool, this screen can be reused. So how do I make it reusable in a nice way? Well, I make a pod out of it. It's like a little framework, right? And then maybe you don't want to bring along the view layer, because the view layer is the thing that you never want to ship along. So you have the pod with subspecs for each. You have interactor as a spec, the presenter as a spec. They are linked to each other. And if you want this to live, to survive, you need to support semantic versioning, okay? If you don't know what it is, you need to Google that, because otherwise, you're lost on day 2, especially if you have frameworks or this sort of approach. And of course, I would recommend, but it's not definitely needed, that you are in a context of a dependency injection container, because while at the beginning it seems a bit weird, it's actually very sorry, it's actually very it's finished. Good. Well, clean architecture, those are 3 reading actually watching suggestion. Clean architecture and design by Uncle Bob. Integrated tester scam, and also simple made easy. Very much concrete on this design pattern, why this is a good design to do those sort of tests, which are called isolation checks. and this is interesting as well. No such thing as one size fits all. So this is an approach. Okay, maybe it works, maybe it doesn't with your projects. If you're a startup, probably is not as strong, but that's it. Thanks a lot.
Okay, my question is, what do you think about combining, for example, VIPER model and, for example, for some very simple model to use, for example, MVC? If you just have about screen, you should just show some text and it's all.
That's a great question, because if you just have an about screen, I would kill you if you do something like that. As an architect, are you crazy? No, don't do this, because it's way, the about screen, if it's 100 lines only in the view, because maybe the about is even our code, I don't know, I'm just guessing, right? You're right. What we always mentor is, the right screen, the right module with the right architecture. That's why we wanted it black box, because then we can mix and match. But eventually, and I see all the guys in the company that they're picking this up and say it's very good because, first of all, okay, we as a policy impose you to test. You cannot ship code without tests. And it's frustrating because testing is difficult if you don't know how to do it. And you estimate, oh, this task is 4 hours, half a day, good. Then you say, oh, I forgot to estimate tests. And after 1.5 days, you finished. So your tests are taking much longer than your code base. Why? Because you didn't write your original source code better. Because everybody says that test-driven development, nobody does it. We don't do it, even if we say we do it. This is a trick that you are forced to do as some sort of test-driven, but given that you have to figure out the protocols before the testing comes up. And one of the biggest comments I had is, look, I have to write a lot of protocol in classes, but then I can test, it's very simple to test. And also, I know where to put my hands, because I jump into someone else's code and, okay, this is a business rule, that has to be in the INTERACTOR. Oh, this is a bug into the view. Okay, I'm jumping here. Oh, this data is not, the internationalization didn't work. So you know exactly where it is, the problem all the time, because there are many, but there's more.
My question is, this kind of separation creates a lot of classes, lots of boilerplate. So do you know some kind of tools that would help with this to generate most of it? Yeah.
This is a question that I get a lot, and there are tools out there. I don't use any tools, and the reason being is that if you have this in mind, basically, you don't want any tool to generate any scaffolding, because where is the scaffolding? Is just to write public protocol and the name of the module, a pending builder. Yeah, you can do that, but what I try to teach all the time is stop and think about what is the function that you want to add in here. What is the name? Okay, this is standard. I want it always like that, but in general, is there anything here? Okay, tell me, the interactor, what you're going to ask to the interactor. What is the business of the interactor? So I want you to write every single letter, even the name of the module here. One of the crazy things of those days with Swift is that we have to work with Xcode and AppCode, because we refactor like crazy all the time. All those names must make a lot of sense. And Xcode doesn't even do find replace, basically. Appcode does it a bit better, but then compiling is so slow, so we jump here and there. So no, I don't know. There are definitely tools out there, we just don't use any. That's simple. Thank you.
Hi, thanks for the talk. I actually have 2 questions. One is, I don't think we have time during the presentation, but I'd like to maybe ask you a question later on about the way you handle passing data between modules.
It's very simple. So it's either that you produced a simple amount of data that goes as an input parameter. Sorry, I have a slide. I just had to skip it. Okay, here. So see, the router produced the object, the selected object location widge, and passes to another guy, builder. This builder here represents a screen that displays the weather for just one city. If you don't provide one city, you cannot build the module. So this is one way. If you're, you know what I mean? It's like a function. This function produced an output, and this function wants it as an output. Otherwise, you don't build it.
So you put the data that you want as dependency injection into the
it's not really dependency injection in this case, because this router here will get injected by the concrete implementation of this builder. Okay, the next one. And what method does it use? Use a builder build module, right, with cd. Close the module, get what? A UIV controller, push it. So another interesting thing is that we let the before router doing the push rather than the after router, but that's an interesting point. So yeah, basically, think about this builder as a function. So it doesn't inject anything. It's more passing a function to something that was injected.
Okay. And another question, don't you think in the VIPER paradigm that the presenter has a bit too much responsibility?
That's why I told you there is another component which I didn't dare to add in here. We have a thing in the middle which is called view model builder, and it's very powerful because you can change it as a dependency injection as well. So you relieve it by, but you know, if I tell you there is yet another component, you're going to kill me because those are already many.
What about relaying information from the view to the interactor? Because there's like a guy in the middle that doesn't do anything. Right?
No, it does. It does orchestrate the thing. You never bring information from the view to interactor is very seldom in general. So the view may say something like, you know, I'm ready to display, but what does it mean? You know, you can't jump to the interactor. Of course, you know, I get many complaints, you know, if you have to change something and you have to touch many components, it's true, you have to touch many because the responsibility is very, you know, everyone has his own responsibility. And if you start merging stuff, all of a sudden you're going to feel like, why I don't put the presenter within the view controller? And then you end up with the big blob as well. So there is always this trade-off, you know, and so that's how we see that in general.
Okay.
There's a guy there which is very eager.
Do you have energy to answer more questions?
Yeah, I have no problem.
Brilliant. For those who want to leave, you can leave for the break.
Yeah, I don't have problems.
We'll have a great panel, I think.
Hi. Hey, can you please go back to the slide where you're defining your presenter?
The presenter. Is here.
No, the actual interface, the protocol. Sorry.
Oh, right. INTERACTOR.
Underkai. Disgusting.
Yeah. Presenter.
Yeah, so I was thinking like when you're on the view knows about the presenter and it's calling, and the presenter is calling back into the view. Yes. Have you thought about exposing the signals from the view in a generic way and then the presenter done? That's one. And the second one is getting a more data-driven approach where you're not calling on methods, you're just passing pieces of information that are domain-specific, and you're just interpreting each one of those signals. So if you start going in that world, you would like to add some sort of reactive behavior to yeah. What I can tell you is this. I personally never tried to do that for an obvious reason. We are now writing most of our stuff in Objective-C still, and I don't want to engage with reactive Cocoa. I want to engage with Rx Swift as soon as we move to Swift. Okay, so I don't have the exact answer on that. What I can tell you is that the Android guys, which I work with as well, while pitching this design, they picked up 100%. They have some issues when you rotate the screen and everything gets destroyed and blah, blah, blah. And they use reactive on top of it. So that's for sure. It's totally doable, but I can't tell you exactly how because I've never done myself, so it would be cheating, you know. And trying to use more anion types to define like the algebras or the operations that are available for your use in your presenter rather than using protocols. Because when you're exposing a protocol, you're just exposing like a menu of all the possible things that you're sending. And when you're exposing an algebra, an anion type, you're just allowing one possible state or one possible action. Yeah, that would be interesting. I wouldn't know how to do that, but we can discuss and you can show me how to do that, to be honest. This is somehow very basic, because those are just functions that you call on a protocol, but in another way, they're very simple and elegant in some sense, because it's simple. You know, you can't really get misled too much by this, right? It's very bare bones on contracts.
We need to finish, sorry. Yeah, thank you very much.
Thanks, guys.